my name is Dan Trane, and apart from working on this Hanseatic Science Cloud, I also happen to be on the team that is developing the software behind the Hanseatic Science Cloud itself. And yeah, with me I have Martin Hansen, and we also have Claudio Piga, who is the director of the center that I work at. So without further ado, I will now go into and show you the Hanseatic Science Cloud and what the platform can sort of do. So I want to start by mentioning that this is in the prototype stage. So there will be things that are more prototype-like, and that comes mostly in the form of the way that the system is currently configured. So for example, some of the service providers that are hooked up to the system will have fewer hardware resources available to it. And some things aren't fully configured, as we can see here on the login screen. So in a production scenario, you would normally log in with federated login, meaning your normal organization credentials. In this case, it isn't set up, so we'll just proceed with normal username, password login. And security first. All right, so we're now logged into the platform. And the first thing that I want to show you is a small introduction to the project that we have inside of the Hanseatic Science Cloud. So up here in the upper right corner, we have this selector here, which allows me to switch between different projects on the platform. So right now I'm in my workspace, which is a sort of personal workspace where I can do some of the work by myself if I need to do small experiments. But in this case, it's a lot more interesting if we look at sort of collaborations. So I'll just switch over to the small demo project I've prepared. And I can now go and show you the members of this project. So as you can see in here, on the left-hand side, we have a bunch of members in this small demo project, and each member of the project has a role associated with them. So there are 3 roles in total. You can either be the PI, of which there's exactly 1, or you can be an administrator or a normal user. And all of these project members can then be partitioned into groups, and each group can have several members, and each member can be a member of many different groups. So in this case, we have set up a few groups, like one for all users, one just for the collaborators, the core team, for the leaderships, and for any students that might be part of a project and that sort of thing. And all of this can be configured by the PIs and administrators of a project. So it's entirely up to them how they want to sort of structure their project. We'll circle back to the groups in a bit. So remember that they exist. So instead of talking about all of the technical stuff behind it, I want to just jump into the action. So one of the things that this platform allows you to do is to work with data, and it also allows you to then do computation on this data. So when we click on the sidebar icon here for files, we'll be taken to a page with a list of virtual drives. And you can think of these virtual drives similar to what you would find on your own machine. So it is the equivalent of a C drive on Windows, or really just any other drive. It could be a network shared drive. This all feels very similar. It's more or less the same concept we're working with. So inside of a drive, you will of course find files and directories. And so we can jump into one of these drives. And here we'll just find the files, and we can do the operations you would sort of expect to be able to do for basic file management. So we can jump into any of these folders and we can see the files. We can create our own folders. We could go into any specific folder, and in here we could say upload a file, like uploading a picture of a dog, as you would normally do. And on these files, you can do what you would expect to be able to do. So you can rename them, you can download them, you can copy them around, you can rename them, and you can delete them. It's the sort of thing that you would normally expect to be able to do. Right. And so let's just delete this folder here that we created. So I also want to show you that you can really create these drives as you want. So in my raw data folder, raw data drive, I right now have a processed folder of data. And obviously it shouldn't be in the raw data, it should be in some other drive. So we can go in and create on the drive. And let's call it process data. And when we're creating a drive, or even after the drive has been created, we can choose who has access and what level of access they have to this drive. So we might want to say that our collaborators should have read data to this data. Our core team and leadership should have read-write access, and maybe the students need read access also. And so we can create this drive, and it'll appear here. And we can go into it, and it's empty. So we can now go back to our raw data, and then simply cut it, and then paste it as you would expect to be able to do. So now I want to do a small little intermission and talk a bit about what's actually going on behind the scenes. So what the Hanseatic Science Cloud does is really to, at a technical level, connect users to different providers of these storage and compute facilities. And right now in the Hanseatic Science Cloud, we have 4 service providers in total, coming from 3 different organizations. And today I will be showing off 2 of them. And so one thing that's very core to the way that this works is that each service provider can really deliver a different service. So service providers don't have to be identical. Really, service providers can come with their own strengths and really deliver the service that they want to deliver. But that also means that you won't necessarily get the same thing from every service provider. So some service providers might support one thing while others don't support that thing, but they support something else. And that's both at the software level, but also at other feature levels. For example, the project management feature I just showed doesn't necessarily work at all service providers. It all depends on what exactly and how the service provider is integrated into the system. Right. And so how do you actually get access to these service providers? I just want to be clear. Here I'm talking more about a hypothetical production grade running service of the Hanseatic Science Cloud. So there are 2 ways you would be able to gain access to one of these service providers. And one way is that you happen to already have an account at one of these service providers. And in that case, the service providers are able to help you then connect that up and be able to access the service provider from within the Hanseatic Science Cloud. And the other way to do this for the service providers that do support it is to apply for access directly from within the platform. So here on the dashboard, if we scroll down a bit, we can see that there is this button that says apply for resources. And if you click on this, you'll be taken to a form. And here the process is the same if you're asking for an extension to an existing project, like we have here, or if you're trying to create a new project entirely. So at the top, you would fill out what is the name of your project. In this case, we have an existing one. And then there's some basic metadata information about the application you're making, like when should the allocation be valid from, for how long should it last. And then you need to select from who you're applying for these resources from. So in this case, we'll select this one. And with that appears a form of which specific resources we want to access and how much we need. So in this case, it's fairly simple. We have a single CPU type to select from. So we can select how many core hours of that we want. And then we have just a single type of storage, and we can ask for how many gigabytes we need. If we had other types of compute nodes in such a system, then those would also appear. So for example, you might have machines that have more memory. You might also have different generations of hardware, and you could have more specialized hardware. You could have GPUs and that sort of thing. So those would all appear as different categories in this form. So I can type in some number I want. And then it comes to the application process itself. And so this application is going to whoever the service provider has delegated this responsibility to, it could be themselves. And this, we call it a grant giver inside of the software. This grant giver can then define what the application should look like. So in this case, they are asking for information about the project title, an abstract. Maybe you have some collaborators they need to know about. Maybe there's some specific software needs you have that you can fill out. And then you need to describe what research activities you have. And so if I just fill this out real quick, we can then submit it. And then a notification is automatically sent to whoever needs to approve it. In this case, I believe Martin is able to approve my application.
Indeed. So in this case, I am an admin in the grant giver project, so I can actually approve this application from then. If I have comments or requests for changes and so on, I mean, I could in principle also send these to him before I approve the application. But of course, for this particular example, I will just approve this so we can continue. And there we go.
Yeah. And I also got a notification in the upper right corner, and it also sits down here that it has been approved now. And I believe these resources are now also visible here. Yeah, they look like it's visible. I can't remember what the numbers were before, but they should be here. Right. So with our project extended, I now want to move ahead and do a bit of compute, which you can also do on this platform. So if you go to the application side here, you'll be presented with a big catalog of different software that's available. And as I said, not all software is available at all service providers. So for that reason, we have this filter here, which allows us to select which specific service provider we're interested in running stuff on. So if I just change the filter to show only the applications that's available on the provider I've shown so far, we're presented with this. So you can sort of favorite an application and they'll appear here at the top. We also have some featured applications, and if all else fails, you can always go in and then browse by sort of category. So the first thing that I want to show is sort of a remote desktop style application, which is not in there.
Sure.
Maybe it was. Yeah, there we are. And so when you go and want to start an application, you're presented with this form again. And so you have to select what type of machine you want to run it on. And here you're given the options of what you have access to already. So in this case, we can select this relatively small machine. And then we can sort of go through and select what other things we want to attach to this job. So for example, we can select some folders. So we could go in here and say that we want to put in the other software we have in one of our drives. And then there's a bunch of other options that I don't want to go into right now. And I've cheated a bit, and the job is actually already running. So we can just jump over to it now. And so when the job is running and has gone through the queue, it'll look roughly like this. So we can see the log output from the job. We can see how long it's been running, and if the provider supports it, you can also extend the job. And a big part of this is for interactive applications. As I said, this is a remote desktop. So you're given the option of opening the terminal to the job, or you can open the interface, which in this case will open up the remote desktop. And on the remote desktop side, you have pretty much what you would expect. It's a remote desktop, and you can do with it what you would normally be able to do with a remote desktop. And this, for this service provider specifically, it gives you a secure, sort of isolated environment where you can really do a lot of things. And this, in this case, also includes being able to install your own software inside of the remote desktop. So for example, we could go ahead and just do normal apt get install like you would do on Ubuntu, which is what this remote desktop is based on. And it will then go ahead and do the normal installation process. And And just to illustrate what else you could do with a remote desktop that you might not be able to do with other types of application is like more advanced visualizations. So I prepared this little script that will open up a 3D model and show it to you. And unfortunately, the hardware we're running on here is quite slow, so it'll take a few seconds. But you can see that you can do many things on these sorts of remote desktops. Yes, we do want to continue with installation. And so inside of this, you can, of course, also access all of the data that was mounted. There we go. It's coming along. So we mounted the software drive, and we can also see the software drive in here, and we can do changes to the files, and that will go into the file system, and we can see them in both directions. So if I were to edit a file in here, we could then immediately jump into the file viewer on the platform and see the changes there. And yeah. And while that is running, let's actually just jump to another type of application that you might want to be able to run. So one thing that we know is very popular is to be able to sort of create these public dashboards of your data and be able to present sort of the data that you worked on. And one such application is this Dash application. So the way to set this up is very similar to the other one I just showed. So you select the machine type. Here there are some mandatory parameters, so you need to select the source code of the dashboard itself. So I have that prepared in here. And then you just need to select the main file. And then you click submit, and then it goes into the queue. And in this case, it should be relatively empty and go pretty quickly. So for this specific service provider, it supports basically 3 types of applications. So one we've just seen, which is the remote desktop style application. This is another interactive style application, which presents the output as a sort of a web application. And the third type of application that there sort of is just a normal batch application where it runs at some point, and then you can get the output later from the file system wherever you decided to put it. So we can go ahead and click Open Interface, and here we get this interactive application, which if you want to, you can also share with others. That requires you to set an option on the screen before where you want a public link available to it. But this is, yeah, fully interactive plots, and we can switch around and, yeah. Right. And I think that's it for the service provider we have here. So now let's move on to more traditional HPC. So we have another service provider configured on this system, which runs a traditional HPC cluster with Slurm as its scheduler. So Martin, I believe you should be able to invite me to a project which has access to this.
Indeed. So in this case, you can imagine that I am the PI of another project, and I have a given set of resources that I now want to share with my collaborators. So of course, I can now invite my collaborator into my project, and in this way, give him access to the resources that I have access to. So I'm going to invite Dan now into this project that I have. And he should get a notification. Very good.
And yeah, right here on the dashboard, I can see the invitation, and I can now, of course, accept or decline it. I think the most interesting thing is to accept it. And hopefully everything is working. I now have access to the project, and I can switch to that by clicking on here. And just to illustrate what a project actually does. So on this page, we have all of these drives, and all of these drives actually belong to the project itself. So what happens when I switch between these projects is that the view of which drives and jobs you have sort of switches around. So if I click on this, then it only shows me the drives that are actually in this project. But apart from that, it's all very similar. The user interface looks the same, even though that the underlying systems are really quite different in how they work. But you still get sort of a uniform interface to this. So one thing that this service provider supports, which the other one didn't, is that you can get sort of an integrated terminal directly into the UI here. So on here we can really just do what you would normally do with a Linux shell, which is what the system has available.
And for those that are already, maybe just for those that are already familiar with this, so what we're actually working on now is a normal Slurm system, but we are going, let's say, to the Slurm system through this web interface instead.
Yeah, exactly. Yeah, and so one more thing I want to show with this file browser that I didn't do before is that you can actually also open it up and then do edits from within this user interface. So here we have a very simple C program that currently does nothing. And I'll just change it to actually produce a bit of output. And also just to illustrate that this is actually visible in the shell I have in the bottom, we could also open it up in another editor and see the exact same change here. All right, so I'll now try and actually submit a job to this Slurm system. So I'll go up here and change the filter to show the applications that are available on this service provider, and that changes the view around quite a lot because it's a lot of different applications that are actually available here. So one application we have is just a very generic one that's called Slurm script, which really allows you to do anything you want and submit it to the Slurm system. So here we can go to the script and then we can select to edit it. I'll need to quickly say that I want an input directory. And then inside of the script, in this case, I'm imagining that we simply compile the program that we just wrote and then run it. And so that should hopefully look something like this. So we can save this for later. And apart from that, the user experience is more or less the same. So we have a few options for the machine types here. And let's just select the biggest one. And before I forget, this system is quite full, so I need to use the reservation. There we go. The timed out at a convenient time. So we should now be able to see that this job has actually been submitted somewhere in here. It actually already finished. Okay, so that's why. Yeah. And so we can see that this generated more or less the script that you would imagine. So it compiled the program and ran the program. Right. And let's now actually do something a bit more interesting that you normally can't do on the Slurm system, at least not that easily, is to run an interactive application. So one of those is Jupyter Lab. And here we don't need to edit the script at all, so we can just go in and select which folder we want it to run in. And for that, I need the actual notebook I want to show. Like maybe I can't show this now. You know what? I'll show it like this instead. And here we go. So this is another sort of common thing that you can normally do on these more interactive systems, Jupyter notebooks. And then here you can see that it does this sort of, what is the literary code, I think is the term. Very long time since I've used that. And in these we also have these sort of interactive plots that you can look at. Yeah, I think that's roughly all we wanted to show for this presentation today.